All right, let's take the formula out and actually put some numbers to it to make it a little less scary. So what I've got here is a pyramid. The side base, the length along the base, right here, S, is 15 feet. The slant height, L, is 12 feet. That's the distance up the side of the pyramid. Now, for perspective, I need to remember that there is also an altitude to this pyramid right in there that's not 12. I don't know what it is, and the good news is for finding surface area, I don't need it. But I also don't want you guys to get in the habit of thinking it's never going to be a factor, because when we do volume, that's the measurement we use, not the slant height. So you kind of have to keep some perspective here. Keep kind of everybody in the same place. So when we go to find the surface area, so surface area, the formula is that there's one base in my pyramid plus half perimeter slant. So let's see. It's a square pyramid, so the base is going to be 15 squared, which is, I want to say 225, but I don't want to be wrong. Okay, shoot. 225 square feet. Now that I got by just saying, hey, that this base down here, that right along there, that's 15 by 15, or 225 square feet.
Oh, because it's a square.
Because it's a square. Now, the four triangles, you call it the lateral area, the wraparound, the four triangles all leaning on each other, they get all done together in this 1/2 perimeter, which is 60 feet, times the slant, 12. Now, it's 60 because that's 15 plus 15 plus 15 plus 15 plus 15. You know, it's 15 here, it's 15 here, it's 15 along the back, it's 15 down this here. Yeah. And then when I figure out what that is, let's see, that's going to be plus 30 times 12 is 360 square feet. And that gives me thus a total of 585 square feet. Now, as I was saying when we looked at the formula, and people were like, if this formula itself is too hard to memorize, you can break it down into 5 distinct pieces. You have your base, which is a square, that I think we should be pretty good at saying, hey, that's 15 by 15, or 225. And then I have these 4 triangles. Half of 60 times 12. I've got my 4 triangles here. Each triangle is 15 along the base and 12 high. So they have an area of half 12 times 15, which means that one side of the triangle has an area of 90. Except I got 4 of them. So 4 times 90 puts me at 360. So the overall area is 225 for the base, plus 360 of those 4 triangles. And either strategy still gets you to the same point. That's whichever one you like better. So if you don't want to try to memorize a new formula that covers surface area of a pyramid, you can still fall back on the, I'll just break it down to pieces and add all the pieces up. It's a matter of what you're more comfortable with. The height? The slant height? Yeah. It's right here. It's this height right here. Because that's the distance going up the side of the triangle. So when I peel that piece away, that triangle off, that's the actual height of that triangle now. Yes. Which is the height of... You don't for this problem. We don't need it. You mean the green one in the middle? No, that's the 15.
No, down in the little picture.
Oh, that height. Yeah, because that is the 12. Here, let me try this. If I take my pyramid, so there's my pyramid, I'm going to take this side and peel it off. Okay? That is still going to have a height of 12. Well, as I pick that triangle off and set it aside. And that's what this triangle right down, these 4 triangles down here.
If you keep it on the 3D thing, then it's 12 as a slant.
Yeah, because it's 12 because it's leaning in on it.
Oh, I see. The height is.
It's
Right.
the height of that side triangle.
Yeah, and this is where pyramids get weird because you've got the height of the pyramid itself, which is not the slant height. But when I peel that triangle off, the slant height of the pyramid becomes the height of the triangle side. Okay, what you got?
Can you know how each base can be different for each pyramid? So is there like potential for an infinite pyramid, like side-wise, or like does it turn into a circle base at one point?
Oh, as I keep making, as I go from a square to a pentagon to a hexagon, and eventually it turns into a cone.
What if you make it so big that it just doesn't?
It does eventually. If you get to an infinite number of sides, you're now looking at a cone, which is why the cone formula is what it is. You can actually, when you get into calculus, derive the cone formula by taking the limit as number of sides approach infinity. It's kind of neat math, but that's down the road.